What's up, everybody? It's Dan from SageMathTutoring.com and back with another video covering a review sheet for a student of mine. So let's get to it. It's algebra and pre-algebra and stuff. All right, problem number one. Write an equation in standard form of the line that passes through this point and has a slope of 4. So this is what standard form looks like, where the leading coefficient a is going to be a positive integer. Yeah, so let's get to it. I think probably the smartest thing to do is to utilize a tool that we call point slope form, which is this structure right here, okay? Using point slope form, because the reality is we have a point and we have a slope. So we could call this point x1, y1. Of course, the 4 would be our so-called m. And we're going to have y minus -3 equals 4 times x minus 7 in this case. Now, when we have that, it's going to be y plus 3 equals, and distributing the 4 will give us 4x minus 28. And we have really come a long way, but the thing is we want to turn this into something that looks like that, which means the x's and the y's need to be on one side and we need a constant on the other. So let's go ahead and subtract 4x from both sides, which would give us negative 4x plus y. And if we subtracted 3 from both sides, we would also have equals negative 31. Now, it is the case that when you're writing in standard form, you want that leading coefficient to be positive. Unfortunately, the leading coefficient is negative here, but we could fix that by just dividing literally everything by -1. And when you divide everything by -1, it just changes the sign of everything. All right, so that's that one. Okay, we want to graph 3x plus 4y equals 12. Now, probably a good way to go is to realize that we have slope-intercept form as a possibility as well. And when lines are written in slope-intercept form, then they're very easy to graph. So my thought is let's convert this into slope-intercept form. And you might notice that slope-intercept form has this y completely by itself. So that's what we're going to do. We got to get this y by itself. And obviously that's going to be a matter of subtracting 3x from both sides. So we would have 4y equals negative 3x plus 12. We could then divide everything by 4, giving us y equals negative 3/4 x plus 3. At that point, we have the exact same equation. It's just that it looks different. Okay, this is in standard form. This is in slope-intercept form. Now, when it's written in slope-intercept form, it's very easy to graph. All you have to do is start with the y-intercept. The y-intercept happens to be that positive 3. So that's right here. And then we also know the slope is down 3 to the right 4. Down 3 to the right 4. So it's going to be down 3 to the right 4. And then you could just draw a line between those points there. Okay, so it would be a line that looks like that. Okay, so that is the answer to that one. Let's see. Looking at problem number 3, write the slope-intercept form of a line parallel to the graph of 2x plus y equals 5 that passes through 0, 1. So it's the case that they want us to create a new equation of a new line that happens to pass through this point, but by the way, it's also parallel to this line. Well, if the lines are parallel, that means the slopes are the same. So we already have a point, and we know that we could always use point slope form to construct the equation of the new line if we wanted to, right? And we already have a point. We have this x1, y1. So the only thing that's really missing is the slope. So we have to go on a hunt for the slope. And the way that we would find the slope is by acknowledging the fact that if our new line happens to be parallel to this line, then the slopes would be the same. So then the question is, what is the slope of this line? In my opinion, probably the best way to do it at this stage is to just put this in slope-intercept form, because when it's in slope-intercept form, that right there is the slope. So to convert this to slope-intercept form, all you'd have to do is subtract 2x from both sides. We would have y equals negative 2x plus 5, so it's clear that the slope happens to be -2, which means the slope over here also happens to be -2. Because the lines are parallel, at that point, we can go ahead and plug in the numbers. So we have y minus 1 equals -2 times x minus 0. Simplifying that would give us y minus 1 equals -2x. And they want this to be written in slope-intercept form, which means they want it to look, the final answer to look something like this, right? So we got to get that y by itself. Well, that's very easy. All you have to do is add 1 to both sides. So we would have y equals -2x plus 1. So that's that one. Okay. Looking at problem number 4, solve the equation, blah, 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 blah. All right. So the trick with these is you're going to want to get the base that's sort of under the exponent to match the base over here. Now, 6 is sort of underneath an exponent. If you think about it, there's an invisible 1 up there. You can think of it that way. And therefore, you can think of 6 as a base because it's underneath the exponent. 36 happens to be the base here. Now, what you're going to want to do is you're going to want to get the bases to match. And the way to do that is to recognize that, well, 36 is actually 6 squared. Okay, actually 6 squared. So you could therefore write the equation 6 squared raised to the x minus 2 equals 6, we'll say to the first power. That's fine. Now, whenever you have a power, an exponent raised to another exponent, okay, you can multiply the exponents. That is very important for my student who's watching this. You must remember that. And then we have 2x minus 4 equals 6 to the first power. At that point, since the bases match, we can then kind of forget about them because we know just logically that this exponent has to equal this exponent. It's like 6 to the blah equals 6 to the blah. Well, obviously the exponents are equal. So therefore, we can go off to the side. We can say 2x minus 4 equals 1. We could add 4 to both sides. We would then have this whole thing, and then we would be done. All right, looking at the next one. So solving inequalities is exactly the same as solving equations, except you must remember that anytime you're dividing by a negative or multiplying both sides by a negative, you're going to have to switch the direction of the inequality symbol. So we would be dividing both sides by -4, but we would have to then flip this to say that it's this, okay? And then you can also reduce that, okay? So that's all they wanted. They just wanted us to solve it. It's probably the case we're going to have to graph those in the future. Okay, looking at this one. Okay, so I was correct. Okay, solve the inequality, then graph the solution set. So anytime you have an absolute value inequality, number one, you need to make sure that you understand whether or not it's an or an and. Now, if the absolute value is, we could say, less than, I want you to think of the word and here. And if the absolute value part happens to be greater than the number, then I want you to think of the word greater. Okay? So if the absolute value is less than the number, then it's an and scenario. If the absolute value is greater than the number, it's an or scenario. So we already know it's going to be an and scenario. Now, and scenarios often look like, when you graph them, they often look like a barbell, kind of like that, you know? And by the way, I mean, here's probably the answer. So I didn't write that out, but that's okay. So, and very often, not always, but very often, the ors would look like two arrows going in the opposite direction. There are some exceptions, some weird exceptions. I'd actually be surprised if the teacher gave my students a problem that would be the exception. So problem number 6, the question is then, how do you do it? Okay, great. We now know that it's and, right? We know it's an and situation. So what are we supposed to do with that? Well, we could split these, okay, into two separate equations. One says 1 minus x is less than or equal to 2. And another says 1 minus x is greater than or equal to -2. So you have to kind of split it in those ways. You drop the absolute value symbols. This one is an exact replica of the original situation, except no absolute value symbols. This one is a replica of the original situation, except no absolute value symbols. We have flipped the inequality and we changed the sign of this. So that's 3 differences, okay? Then you solve each one. Well, you could subtract 1 from both sides here. You would have 2 minus 1 is 1. You can then divide both sides by -1. Then it would be x is greater than or equal to -1. You must remember to change the direction of the inequality symbol when you divide by a negative. We're going to do the same thing here, subtracting 1 from both sides. We have this, yeah. And then you divide by -1, you would have x is less than or equal to +3. Okay, so then on a number line, you have critical values of -1, you have a critical value of 3. We know that it's greater than or equal to as opposed to just greater than. So therefore, we're going to have a solid dot. Over here, we have less than or equal to as opposed to just less than. So we're going to have a solid dot, and then you can just go ahead and connect in between. It is the case that x is greater than -1 and also at the same time less than 3. So that checks out. Okay, looking at problem number 7, graphing this, and it's an inequality. It's not just a regular line. Well, at first you treat it like a line, but the first thing you got to ask yourself is, okay, I'm going to graph this line, but is it going to be dotted or solid? Well, the fact that this is greater than as opposed to greater than or equal to means it's going to be dotted. The same would be true if it was less than as opposed to less than or equal to. So this is going to be dotted. And then the y-intercept is 2, so we could put a point there. And we know it goes down 1 over 3, down 1 over 3. So it would be like this, 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 okay? And then you could kind of do it over here, kind of reflect it there. And then at that point, you would have this dotted line, okay? Dotted line. So that's that. Then they say graph it. Well, we kind of are halfway there. We graph the line part. But then you need to acknowledge that you're going to be shading a particular region either above or below the line. The shortcut that I prefer for my student watching, just know this might be different than what your teacher says. But the shortcut that I prefer, that in my opinion is the best once you get the hang of it, is to associate y with height, like the height of the shaded region. Now, apparently the height of the shaded region is greater than the line. We can think of it that way. The height of the shaded region is greater than the line, meaning the height of the shaded region is above the line. So that means we are going to be shading all this. Okay, so that's how that works. Graph the following system. Okay, no big deal. Ask yourself, is that going to be dotted or solid? Well, it's going to be dotted. So you start with the y-intercept of 1, then you're going to go up 1 over 3, up 1 over 3. So then it's like this, 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 and then your this, and then your dotted line-ness. And then it's like, okay, cool, y is less than that, so the shaded region is going to be below that. All right. Now, looking at this one over here, y is less than or equal to 2x minus 3. Okay, fine. Let's start with the minus 3 y-intercept, which is right here. There's secretly a 1 under there. That means the slope says we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and so on. All right, also I should have asked myself, is it going to be dotted or solid? Well, this one's going to be solid. All right, so it's a solid line going through those points. It also says that its y is less than or equal to, so that means the height of the shaded region is below that line. So we're looking at this shaded region here. Then you ask yourself, okay, where's the double shaded region? The double shaded region is all of this. And it is the double shaded region that is your answer. Okay, so when the teacher says, what's to graph the solution to this system of inequalities, what the teacher is really saying is graph that double shaded region and make sure it's clear which region is the double shaded. All right, problem number 9, using elimination. Yeah, so I feel like if this thing was just a -4y, then it would cancel with this one. So we could turn this thing into a -4y by multiplying literally the entire bottom equation by 2. And as a result of that, we would have 6y plus 4y equals 20. We would have 8x minus 4y equals 8. And then you could sort of add the bottom equation to the top equation. These would cancel as a result. Next thing you know, you have 14x equals 28. Dividing both sides by 14 gives you 2. So now we know that x is 2. Since x is 2, you could just pick any of the two equations, plug 2 in for x, and figure out what y is. I say we start with, or use rather, the top equation. So we're going to say 6, not times x, but times 2, plus 4y equals 20. We have 12 plus 4y equals 20. Dividing or subtracting 12 from both sides gives us 4y equals 8. Dividing both sides by 4 gives us y equals 2. So we have just solved the system. Turns out that x is equal to 2, y is equal to 2 as well. Okay, simplifying that expression right there. Well, you know, I have like a different way of going about these than others. I'm going to try to make it easy. I'm going to make it easy as possible for my students. So what you do want to do is you definitely want to find the prime factorization of 75. Now the prime numbers are 2, 3, 5, 7, 11, 13, and so on. Sometimes it's nice to have a list of them sort of off to the side. And then you look at your number and you ask yourself, is 75 divisible by 2? No. Is 75 divisible by 3? Yes. So it's 3 times 25. So you do that. Now this right here is a prime number, so you just leave it there. Then you look at 25 and you ask yourself, is 25 divisible by 2? No. Is 25 divisible by 3? No. Is 25 divisible by 5? Yes. So you split that, and lo and behold, next thing you know, you've got prime numbers at the tips of the branches, which is exactly what you want. All right. Now, with regards to the variables, for my student watching, what you might want to do at this stage of the game is just rewrite that 75 as 3 times 5 times 5. And you could do the y 4 times because that's what's happening. And then you could do w because that's what's happening here. And since you're doing the square root, there's really secretly a little 2 there. All right. And what you're doing is you're looking for pairs of stuff, and you can go ahead and circle the pairs. So there's a pair of 5, there's a pair of y's, there's a pair of y's, and there's a pair of w's. Now, anytime you have a pair of something, just one of those goes out front. So in other words, we have a pair of 5, so that means only one 5 is going to go out front. We have a pair of y's here, so we're going to have one y go out front. But we have another pair of y's, so we're going to have yet another one y go out front. We have a single pair of w's, so we're going to have a w go out front. And then you basically just kind of look at what's left over. What's left over is 3, this 3 right here, and a w. And then you're basically done, except that 5y part could just be 5y squared, w. All right, so for my student watching, you might want to do it that way. Obviously, you need to have the skill of prime factorization. You need to be somewhat aware of what prime numbers are. You need to recognize that once you finish the prime factor tree, which, by the way, you know you're done when you have prime numbers at the tips of the branches, okay? Then you can rewrite 75 as literally the tips of the branches, 3 times 5 times 5. You can then expand all these other guys and then just search for pairs. Whatever number is here, if that says 2, that means we're looking for pairs of 2. Okay? And then go ahead and circle them. Remember that who goes out front? Well, only one of these, 5. Who goes out front? Well, only one y. There it is. Who goes out front based on this one? Well, only one y. There it is. Who goes out front here is only one w. Okay, so looking at problem number 11, simplify the expression. Okay, that looks terrible. So what we would do is take advantage of the fact that whenever there's really 2 laws that my student needs to know. Number one, anytime you have an exponent on the outside like that, it gets applied to both of the things. Okay. Another thing is, it's the case that anytime you have a power raised to another power, we already talked about this, you can multiply the exponents, so that just becomes a to the 18th. Okay. So those are the 2 laws. We'll call this law number 1. We'll call this law number 2, even though I presented it in the opposite order. So with regards to the first thing, there's really not much we could do here. With regards to the second term, we could employ law number 2 by, in a sense, distributing, you could think of it that way, the exponent there. And to be fair, you could do the same here. Okay, so let's kind of rewrite everything based off of that. So we have 4a cubed n to the 6th, 4 times plus 4 times a to the 3rd raised to the 6th, and then n to the 6th. And then we have plus 4 times a to the 3rd times n squared to the 3rd. All right, now at this point, we can simplify this situation further because I feel like we only really need. Okay, so we could simplify this thing further by using law number 1, and you could also use law number 1 right here. So you would have 4a cubed n to the 6th plus 4 times a to the 18th times n to the 6th plus 4a to the 3rd times n to the 6th. Now it's the case that these happen to be like terms because the exponents hovering above the a is the same, and the exponent hovering above the n is the same. So that means that it's like terms, which means that that part can combine, which means we could say 8a to the 3rd, n to the 6th, and then we still have that plus 4a to the 18th, n to the 6th. Okay, so that's that. Just like I said before, you're going to want to get the bases to match. It's the case that 256 is secretly 4 to the 4th power. So we could rewrite this entire situation as 4 to the 3x minus 2 equals 4 to the 4th power. At that point, we know that these bases are the same, which means that these exponents must be the same, which means we could actually ignore those red bases. We could create an entirely new equation saying 3x minus 2 equals 4. Adding 2 to both sides gives us 6. Dividing both sides by 3 gives us 2. And then we would be done. Okay. Describe how the graph of g of x equals 3 to the 2x is related to the graph of f of x equals 3 to the x. Okay, so let's see. Best way to explain that, let's look at this scenario. I know this is kind of crazy. So if you have an exponential function, the a represents a vertical stretch or compression. The b is just the base. The c represents a horizontal stretch or compression. The d represents a horizontal shift to the left or right, and the e represents a vertical shift, vertical shift up or down. This is left or right. So when it comes to the comparison that they're asking us to do, this is the like original situation, but now we have that 2 out front. So we have this 2 that's like right there. Now that corresponds with this c right here. All right. It's like 3 raised to the 2x. So that's a horizontal stretch or compression. Now you know it's a compression if it's like a whole number integer that's greater than 1, and you know it's a compression. That's how you know it's a compression, and you know it's a stretch if this is a fraction. So this is a horizontal compression. Horizontal compression. But it's a horizontal compression by a factor of, it's always going to be 1 over c. So it's going to be a horizontal compression by a factor of 1 over 2. Of 1/2. Now what that means graphically, if you were to graph the original thing, which is y equals 3 to the x, it would just look like this. But if you were to graph y equals 3 to the 2x, it would be compressed like that. Okay, so every sort of x value would be half of what it used to be. It's something like that. Okay, it gets pushed in towards the y-axis. Okay, so that's that one. Looking at problem number 14, factoring that one, I'm a fan of using the bomb method for these, which means I would first find what I call the magic number. 6 times 21 is 126. I then ask myself, what are numbers that multiply to 126 but add to 23? And that would be, it looks like 9 and 14, because 9 times 14 gives you 126, and 9 plus 14 gives you 23. So then what you do is you rewrite the entire thing, except you explode the middle term into plus 9x plus 14x plus 21. At that point, you can do something called factoring by grouping, where you factor out the greatest common factor. Greatest common factor of the first pair is 3x, so you'd have a 3x times a 2x plus 3, factoring out a 7 in the next pair. You would also have a 2x plus 3. Notice how these green parentheses match, which is a sign that we're doing things correctly. So that would give us a scenario where you would be ready to actually factor the whole thing. Now the first parentheses is the repeat. That's going to be 2x plus 3. And the next parentheses is going to be based on all the other stuff that's surrounding the green parentheses, in which case it's 3x plus 7. So then you're done. Okay, looking at problem number 15. Yeah, I would do the same thing. So 9x squared minus 12x minus 5. Bomb method, we have negative 45. Two factors of negative 45 that happen to add to negative 12. Well, that would be probably positive 3 and negative 15, because if you multiply those together, you would get negative 45, and if you added them together, you would get negative 12. At that point, you can rewrite the whole thing, explode the middle term to say plus 3x minus 15x. That's the whole purpose of doing the previous step. Then you can do factoring by grouping. We would have a 3x on the outside here, and then you would have a 3x plus 1 on the inside. You would have a negative 5 on the outside here, and a 3x plus 1 on the inside. At that point, you're ready to factor. Remember, the repeat parentheses comes first, which is, right here. And then with regards to the other parentheses, it would just be all the other stuff that's surrounding the repeat parentheses. So that's that. All right, so that's how you do that one. All right, hopefully this was helpful, and I will talk to you later.